Hello, welcome to my channel. In this video, I'll be talking about linear motion. Simply put, linear motion is motion on a straight line. I'll first of all talk about speed. What is speed? Speed is equals to distance traveled over time. It's a scalar quantity and it's measured in meter per seconds. Okay, which is similar to velocity. What makes it different from velocity is that it is a scalar quantity, while velocity is a vector quantity. Velocity is displacement. Take notes. Displacement over time. It's a vector quantity and it's also measured in meter per seconds. Speed is distance over time. Velocity is displacement over time. If you want to know the difference between the displacement and the distance, you can check out my video on scalar and vector quantities. You'll see it there. Acceleration is change in velocity over time. Okay? It is given as final velocity minus initial velocity divided by the time. This is for a constantly accelerating body. Okay, and it is measured in meter per seconds squared. When acceleration is when acceleration has negative value, it is called deceleration. Deceleration. Okay, and as you know, it's a vector quantity. Acceleration is a vector quantity. Now, there are important equations of motion which we are going to talk about. And the first of them is from my definition of acceleration initially, I said acceleration is equals to v minus u over t. And if you make v subject of the formula, it will become at is equals to v minus u, right? And if this comes to the side, v will be equals to u plus at. This is the first equation of motion. Okay, take note of that. You will need it in a lot of calculations. Now, um, now this distance traveled by a body is average velocity times time. Okay, displacement displacement of a body is average velocity times time. And from this formula, the first equation, we said v is equals to u plus at. If we put it in this equation, it will become what? It will become s is equals to u plus at. Okay, plus u, this u. Okay, this v is this. Okay, and this u is this. Okay, everything divided by 2. Okay, times t, right? This will be equals to 2u plus 80 divided by 2 times t. And we know this is the same thing as 2u over 2 plus 80 over 2. Here, these two cancel 2. And don't forget that we still have t, right? And with this, what we'll be having is s is equals to, and this will be equals to, if we open this bracket, that will be ut plus at squared over 2, right? Now, it will mean that s, this s, will be equals to ut, right, plus half at squared. This is the second equation of motion. Okay. Now, still from this formula, t can be equals to v minus u divided by a. Let's substitute it in this equation. Okay. And if you substitute it, we'll be getting s is equals to u bracket v minus u over a plus 1 over 2 a times v minus u over a squared, right? And this will be the same thing as uv minus u squared over a plus a over 2 times v minus u squared divided by a squared. This square cancel each other like this. So in the long run, we'll be having uv minus u squared over a plus v minus u squared divided by 2a, right? If we say this is 2a, right? This a, if you open this, it will be 2uv minus 2u squared plus, if you open this bracket, this will be v minus u bracket v minus u bracket, right? And this will be equals to 2uv minus 2u squared. Let's open this bracket. This will be plus v squared, right, minus uv, right, minus uv, right, plus u squared, right? Everything divided by 2a. Now, let's evaluate this. This 2uv minus uv. This will cancel out, right? So what we'll be having left is v squared what we'll be having left, don't forget that this s is what we are trying to calculate in here. S will be equals to what we're having left here is v squared plus u squared minus 2u squared, right? That is v squared plus u squared minus 2u squared divided by 2a, right? So u squared minus 2u squared is going to give us what? Let's bring this one to the side. That will be 2as is equals to v squared, right? Minus u squared, right? Good. Now, if we make this subject of the formula, if this come to this side, to become 2as plus u squared is equals to v squared. So v squared is equals to u squared plus 2as. This is the third equation of motion. Okay, what you just need to know about these three equations of motion is that here, what is missing there is displacement s, right? Here, what is missing here is what? Is v, that's the final velocity, and what is missing here is t, that's the time. So take note of that. It will help you to know which equation you are to use depending on the question you are given. That's just the reason why we have these three equations. Okay. Take note of these three equations. These are the equations that you'll be using in your calculation. Note, kindly take note that all these equations apply to a body that is moving with uniform acceleration. If a body is not moving with uniform acceleration, you cannot use any of these equations in calculating either the velocity, the acceleration, or the time taken for such a body. Take note of that. Now, motion under gravity is a concept that has to do with a freely falling object. When you throw a stone up, when you throw a stone up, it will be under free fall as it is going up, and at a point it will stop momentarily here, in which v will be equals to 0. Then it will come down. Okay, this concept is motion under gravity. And some also, we can actually throw a stone from an height here, and when it comes down, that's motion under gravity. Generally, for a freely falling objects, they have a constant acceleration, which is known as which is known as acceleration due to gravity, and it is caused by the gravitational force that the earth is having on this body that's under free fall, and it is given as 9.8 meter per second squared. Okay, so this is the acceleration due to gravity, and it is due to gravitational force. Take note of that. So when the body is moving up, the g is usually minus, okay, and when the body is coming down under free fall, the g is usually plus. So when you are using acceleration due to gravity in your calculation, take note of this. Distance time and velocity time graphs is another concept that you need to understand before you go for exam. And distance time graph, let's say this is the distance and time. Okay, let's say the distance is increasing as the time goes on, meaning that the body is moving away, right? Usually, the slope of a distance time graph, don't forget that slope itself is actually tangent, which is equals to opposite, the tangent of the angle made by the line with the x-axis, that is the slope, and it's usually opposite over adjacent. Okay, and opposite in this case will be the what? Will be the s, that's the distance. So the slope will be distance traveled over the x-axis, which is time, and you know this is equals to the what? This is equals to the speed. Okay, so when you are asked what is the slope of a line drawn on a distance time graph, it is equals to speed, and don't forget that speed is a scalar quantity. Okay, now the velocity time graph. Velocity time graph is usually used to when you want to know the acceleration of a body. Okay, let's say a body starts with a velocity of u here. It can be here, it can be anywhere here. Okay, so when this body move with, when you have a straight line like this in a velocity time graph, okay, if you are asked to calculate the acceleration of the body, all you need to get is the slope. The reason why it is acceleration is because if you calculate the slope of this graph, like I described here earlier, which is equals to opposite over adjacent, you know, that will be v, the final velocity, minus u, right? Which is opposite. The slope is equals to v minus u, v minus u divided by t, okay, which is acceleration. Meaning that if you want to get the acceleration in a velocity time graph, we calculate the slope of the line. Okay. Now, this is true for a body moving with constant acceleration, meaning that the velocity is changing at regular interval uniformly. For a body that is having variable acceleration, okay, you may not have a straight line, you may have a curve. When you have a curve like this, if you are asked to calculate the instantaneous acceleration, okay, of that body, what you need to do is to draw a line tangential to the curve that you have, and you calculate the slope. That will give you the acceleration, instantaneous acceleration at that particular point in time. Now, in continuation of what I've been talking about, I talked about instantaneous acceleration. That is when you have a velocity time graph with a curve, with a curve, which is not a straight line. When you want to calculate the instantaneous acceleration, you get the what? The slope at that particular point in time, which will be equals to v minus u over t, which is opposite over adjacent, right? Don't forget that tangent, don't forget that slope is actually tangent of the uh, curve. So acceleration will be v minus u over t, which is also equals to the slope. Now, for instantaneous velocity, that is when you plot displacement against time and you have a curve, okay? In this case, the velocity is not constant. Don't forget that if you have a straight line for displacement time graph, you know earlier I talked about distance time graph, which was for speed. The same thing for displacement time graph. That will be for the velocity. The slope will be equals to the velocity. Okay. Now, if you have the If the velocity is not constant, you will get something like this, a curve rather than a straight line. And for you to calculate the instantaneous velocity, all you need to do is to calculate the slope of a tangential line that you drawn at that particular point in time. Okay, just get the slope and you will get the what? You will get the velocity, the instantaneous velocity at that particular point in time. Now, having discussed the speed, the velocity, acceleration, and talked about the equations of motion and also the instantaneous, the graphical representation of all of them, and also the instantaneous velocity and acceleration. Now, let's go through some questions to test our knowledge and to reinforce what we have known. Question number one: a car accelerates uniformly from rest to 30 meter per second in 10 seconds. What is its acceleration? Don't forget that the equations that we discussed actually apply to a body that is having uniform acceleration. Okay, so this body that's having uniform acceleration now, we are given, they said it starts from rest, meaning that u is equals to 0. Anytime a body starts from rest, u is equals to what? 0. And uh, it the velocity increased to 30 meter per second, meaning that v is equals to 30. Okay, and we are given the time t is equals to 10 seconds. Okay, now we have u, we have v, we have t, and we are asked to calculate the acceleration. So which of the equations will fit this? You see that it will be the first equation, which is v equals to u plus at, and this will be equals to what? 30 is equals to 0 plus a times 10, right? And a will be equals to 30 divided by 10 equals to 3. So the correct answer is 3. A ball is thrown upward with a velocity of 20 meter per second. How long does it take to reach its highest points? Taking the acceleration due to gravity to be 9.8 meter per second. Now, let's represent it diagrammatically. Let's say the ball from here is thrown up. When it goes up, right, at a point, anytime you throw something up at a point, it will stop and start coming down until it hits the ground. This is how the path usually is, right? Now, so they said the ball is thrown upward with a velocity of 20 meter per second, meaning that the initial velocity here is equals to 20 meter per second. How long does it take it to reach its highest point? And we know that the acceleration is equals to 9.8. But because this body is going up, that will be minus 9.8. Like I said, that when the body is going up, it will be minus. G will be minus, and when it's coming down, it will be plus, right? Now, they said, how long does it take to reach its highest point? So they expect us to calculate the time it will use to travel from this place to this place. That is time, right? So now we have the u, we have the a, and we want to calculate the t, right? And don't forget that when it reach this point, at this point, it will stop momentarily, and at that point, the v, the velocity at that point is equals to 0 because it's not moving. When the body is not moving, velocity is equals to 0. Okay. Now we have v, we have u, we have a, and we have t. Now what equation will fit this? It will be v is equals to u plus at. That's the first equation of motion, right? And we know that V is 0 is equals to U is minus 9.8, right? Plus U is equals to 20, right? Minus 9.8 T. Okay? Now, if we bring this to this side, it will become 9.8 T is equals to 20. T will be equals to 20 divided by 9.8. If you press your calculator, you'll get this answer. Very likely it will be 2 or 2.5. You can do that with your calculator. The next question is, they say a car travel 100 meter in 5 seconds, then 150 meter in 5 seconds. What is its average speed? You know, average speed is equals to V plus U divided by 2. Okay, the velocity here, V, don't forget that velocity is equals to distance, the displacement over time, which in this first case is 100 over 5, and in the second case is 150 over 5. This is equals to 20 and this is equal to 30, right? So they say it's initially travel at this. This is the initial velocity, which is U, right? And this is the final velocity, which is V. So we total the two together, 30 plus 20 divided by 2, okay, which is equals to 50 divided by 2. So the correct answer is 25. Next question, which of these quantities can be negative? Take notes that generally vector quantity can be negative, right? But scalar quantity cannot be negative. You can check my lecture that I did earlier on scalar and vector quantity for you to understand. And don't forget to like, subscribe, and share this video for others to benefit. Okay. Now, if you look at all these are are scalar quantity. Speed, distance, and time are scalar quantity. Only velocity is the vector quantity, and it's the only value that can have negative value. Okay. That is because what is involved is displacement in calculating it. And displacement can be negative because it's vector quantity. The reason you want to know, check my video on scalar and vector quantity. The slope of a velocity time graph, velocity time graph, they said the slope, we know the slope is here, and slope is opposite over adjacent. That is the velocity over time. So which is equals to what? Acceleration. So the answer is this. Okay. An object moving in a straight line with constant velocity, as when a body is moving with constant velocity, it means V is equals to U. So if you say acceleration is equals to V minus U over T, if U, if V and U are the same thing, meaning that it will be equals to 0 over T, which is equals to 0, meaning that a body that's moving at constant velocity will have 0 acceleration. The correct answer is A. Okay. A stone is dropped from a height of 80 meters. How long does it take to reach the ground? Don't forget that here, when a stone is dropped from an height, the initial velocity is equals to 0. Okay. And the acceleration, we know it to be 10, which is acceleration due to gravity. And we know the distance from which it is thrown to be 80. Now you have U, A, and S. So they ask you to calculate the time it takes for it to reach the ground. So which equation are you going to use? Plus 1 over 280 squared. That's the second equation. Okay, you use this, I think you should be able to get what the time will be. Okay, I'll leave the remaining question for you to answer. Take your time, pause the video, go through the question, and try to answer it. You can write your answer in the comment section below and open up discussion for better understanding of the topic. Don't forget to like this video, subscribe and share. After you subscribe, click the alert bell so that you'll be notified when I upload new videos. Okay? Until I see you in my next video, I wish you the best. Take care. Bye bye.